All right, here we go. Math 2, Unit 8, Worksheet 2, numbers 8 through 19. This is Mr. Tretna from Clovis High School, and what we're going to be doing is we're going to be evaluating exponential expressions, and every single exponential expression is going to have an exponent that's going to be a negative. It could be a fraction, it could be a positive fraction, it could be a negative fraction. The base could be positive, or it even could be negative. Okay, before we get started, Mr. Tretna's random thought of the day: replacing W with T in what, where, and when gives you the answer to each one of them. What? Saying what, Mr. Tretna? Replace the W with T gives you the answer to each one of them. Okay, without further ado, let's go through and let's do, starting at number 8, we'll finish at number 19, hopefully. Okay, so number 8, we have 16 to the 3/4 power. Let me zoom in a little bit here so it's easier to see as you're watching it at home. Remember to smash that like button. So when you have that like button right there, smash it, hit it, punch it, press it, whatever you need to do. I need to become a diamond member of YouTube. All right, 16 to the 3/4 power. So whenever we're evaluating, the first step that you're going to do, that you have to do, is you want to take this expression and you want to change it into a radical. Okay, so you're going to put the radical sign. Whatever the base is of the expression, which in this case is 16, that will become the radicand. Whatever the denominator is of the exponent, which in this case is 4, that will become the index. And whatever the numerator is of the exponent, which is 3, that will become the exponent for your radicand. So we're going to find, what we're doing is we're going to simplify in order to evaluate the 4th radical or 4th root of 16 to the 3rd power. Okay, first step, always change the problem into a radical. Then we're going to take the radicand, just the radicand, not the radicand with the exponent, and the next step is we're going to take that radicand and we are going to make a factor tree out of it. Okay, so I have 16, I have a couple of choices. I could go 8 and 2, I can go 4 and 4, it does not matter. Typically when I can go two numbers of the same, I'm going to choose those, just because when I factor it down, it's just like less thinking that I have to do. They will factor into the same portion. So you can see that when I factor 16, I end up with 2 times 2 times 2 times 2, and we're going to write that out. All right, in order to help us evaluate this problem here. Okay, so I have a radical, I have the index of 4, and then 1/16 is going to become 2 times 2 times 2 times 2. However, this exponent tells me I actually have 16 and I have it 3 times. So that means I'm going to have 2 times 2 times 2 times 2, and I'm actually have to write it 3 separate times, and that will indicate to me that I have 16 3 separate times. Okay, that is a very important step. You want to write out, we call this expanding whatever is in my radicand. Okay, now what I'm going to look for is my index is 4, so in order to simplify this, I am looking for 4 identical numbers. Okay, and every time I have 4 identical numbers, and you can see I have 4 identical 2's here, those 4 identical numbers, they get moved to the outside of the radical. So I'm going to have a 2 on the outside of the radical. When they get moved, the number on the outside of the radical is whatever the numbers are identical. I have another set of 4 identical 2's, so I'm going to move another 2 to the outside of the radical. I'm going to run out of room here, I can see. Okay, and you multiply those together, and then I have another set of 4 identical 2's. So when it's all said and done, I am going to have 2 times 2 times 2 on the outside of the radical, so that's 8. 2 times 2 times 2 is 8. And then any leftovers will stay inside the radical. If there are no leftovers in this case, then you just drop the radical, okay? So we're done. So we have just evaluated. We have just said that 8 is the same thing as 16 to the 3/4 power, right there. And that's how we go about doing it, okay? Doing these type of problems. Moving on to number 9, I have 25 to the 3/2 power. So the first step is we have to change it into a radical. Okay, the 25 becomes the radicand, the 2 becomes the index. I'm going to write a 2 there, although it's not necessary. And then the 3 becomes the exponent that the radicand is. Okay? Then I'm going to take the radicand, just the radicand, not with the exponent, which in this case is 25, and I'm going to make a factor tree out of that. There's only one choice for 25. It's 5 and 5. Both of those are prime. Okay, and then my next step is I'm going to expand this radical. So I have an index of 2. I'm not going to write it. Remember, if there's no index, it's implied that the index is 2. And then 25 becomes 5 times 5, but that exponent of 3 tells me I have to have 3 5 times 5s. Okay? All right, so now, since my index is 2, I am looking for 2 identical numbers. So you can see I have 2 identical 5s. Those will go to the outside of the radical. I have 2 more identical 5s. Those will also go to the outside of the radical. You multiply multiple items outside together. I also have 2 identical 5s here, so those will also go to the outside of the radical. So on the outside of the radical, I have 5 times 5 times 5. That's 125. And then any leftovers I leave inside the radical. I have no leftovers, so that means 125 is my answer. So 125 is 25 to the 3/2 power. Okay. Number 10, 256 to the 3/4 power. Okay, so my first step is I'm going to change this into a radical. I take the base, which is 256, I make that the radicand. I take the 4, which is the denominator of the exponent, I make that my index. I take the 3, which is the numerator of my exponent, I make that my exponent for my radicand. Okay, my next step is I'm going to take my radicand, which is 256, and I'm going to make a factor tree out of this. Now, some numbers are obviously a little bit easier to make factor trees out of. 256, not probably my favorite number to make a factor tree out of. However, I'm going to go with 4, and let's see, that'd be 4 and 64. Okay, couple things. If the number is even, it could always be 2 and something. You could always divide 2 into it to see what it is. Okay, 4 factors into 2 and 2. I'm done because both of those are prime. 64 will become 8 and 8. 8 will become 4 and 2. And 4 will become 2 and 2. And then I'm going to do the same with this 8. Factor it down into 4 and 2. Factor it down into 2 and 2. It's always a good habit when you're making a factor tree to underline when you get the prime numbers. The underlines tell me to stop. And now I'm going to take this radical and I'm going to rewrite it, and I'm going to expand it, and it's going to be expanded pretty lengthy, so I want to make sure I give myself enough room. I'm going to have an index of 4, and then 256 becomes, let's see, I have 1, 2, 3, 4, 5, 6, 7, 8 2s. Awesome. 2, 3, 4, 5, 6, 7, 8 2s. Okay, that's just for 256, but I have 3 of them. So I need to do this 3 times. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm doing this. There's a lengthy way to do it. Some of you might be able to figure out a shortcut, but if you do, fantastic, use it. Now, my index is 4, so I'm looking for identical numbers I'm looking for 4 identical numbers. You could see I have 4 identical 2's. I have 4 identical 2's. I have 4 identical 2's here. 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 So every time I have 4 identical numbers, I'm going to move them to the outside. So I'm going to move 1, 2, 3, 4, 5, 6 2's to the outside. So when I'm said and done, I'm going to have on the outside of the radical 2 times 2 times 2 times 2 times 2 times 2. There's going to be no leftovers, so that means my final evaluated expression will not have a radical in it. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, so 256 to the 3/4 power evaluates to make 64. Hopefully that makes some sense to you. Okay, number 11, 64 to the 1/6 power. The first step I need to do is I need to express this as a radical. Okay, I take the 64, that becomes the radicand. I take the denominator, which is 6, that becomes the index, and then the numerator, a 1, becomes the exponent, and I don't have to write a 1. Okay, my next step after I change it into radical form is I take the radicand, which is 64, and I'm going to make a factor tree out of that. That becomes 8 and 8. 8 factors into 4 and 2. 2 is prime, so I stop at that 2, but 4 factors into 2 and 2. Okay, and then I'm going to do the same thing over here with this 8. 4 and 2. 2 becomes 2 and 2. So 64 factors into 1, 2, 3, 4, 5, 6 2's. Expanding this radical, I'm going to end up with an index of 6, and then I'm going to end up with 6 2's. 2, 3, oh boy, I just lost my lights again. This happens all the time. Hey, my lights are back. So I'm going to end up with 6 2's. 3, 4, 5, 6 2's. Okay, and now since my index is 6, I'm looking for 6 identical numbers. And you can see I have 6 identical 2's. Those, whatever's identical, moves to the outside, a 2. There are no leftovers, so that means my final solution is just 2. So 64 to the 1/6 power is equal to 2. Okay, this would just become 2 there. Okay, number 12, 64 to the 5/6 power. All right, this one, some of these are going to be a little repetitive, so we're going to go ahead and we might not have to factor tree the whole thing. But my first step is I have to rewrite it as a radical expression. So the 64, the base, becomes the radicand. The 6 becomes the index. And then the 5 becomes the exponent for the radicand. Okay? And then I'm going to factor tree 64. Now I'm not going to factor tree 64, and the reason is because I just factor treed 64 over here. Okay? So what that means is that when I expand this out, I know that 64 becomes 2 times itself 6 times. So I'm going to end up with 2 times 2 times 2 times 2 times 2 times 2. Okay, that's going to be 1/64, but I need 5 of these. Okay, so I got to write it out 4 more times. 4, 5, 6. 2 times 2 times 2 times 2 times 2 times 2. 2 times 2 times 2 times 2 times 2 times 2. And one more time, I need 5 of them total. So then I have 2 times 2 times 2 times 2 times 2 times 2. Okay, and now since my index is 6, that means I'm looking for 6 identical numbers. I have 6 identical 2's, 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 I have 6 identical 2's. So every time I have identical ones, I move those they get moved to the outside of the radical. So on the outside of the radical, I have 5 2's moved to the outside. I multiply those together. 2 times 2 is 4, times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So that means I'm going to have a 32, and if there's no numbers left over, I drop the radical. So that is my answer to number 12, 32, for 6 to the 5/6 power.